you'll highly likely do just fine on the retake. If, however, you can't come after school and spend time with me, there's virtually no chance you will get a better score. Because you've already spent several weeks preparing in a way that you thought was the right way to prepare. And if it led to a bad score, that's telling you the way you're preparing is flawed. And so I need you here with me so I can help you prepare in a way that will work. And then I know you'll get a good retake score. So that's why I do retake prep. Okay. I got to speed up a little bit. We had a longer discussion on how to make Canvas better, but that was productive. Okay, for those who didn't see the earlier videos, you need to keep track of what we're trying to accomplish here. We have a function. The formula is right there. Please remember, you use this to find a whole bunch of XY pairs. If you graph those XY pairs, you get a picture. Maybe it looks like that. Okay, it doesn't actually look like that, but who cares? It looks like something. Okay, our goal for all of Unit 2 is to do the following. We want a way to be able to go to every single point on this graph, every single point. Like, watch my pen. I'm moving to every single point here. I'm following the curve. We want to be able to go to any point on this graph, and at whatever point we select, we want to be able to find the tangent slope of this graph at that point. That is the entire goal for Unit 2, nothing else.
Can you say that again?
So the only goal for Unit 2 is to take any function I give you. Like, I've now given you a whole bunch of them, the buff sheet, the pink sheet, the yellow sheet. You want to be able to take any of those formulas like this and be able to find at any x coordinate on those formulas, like what you see here, you want to be able to find the tangent slope. That's all we're doing for Unit 2, is finding a way to do that. Okay? Technically, I shouldn't say technically, the way that's actually done is you go to a given point like this, and you draw a slope to the left, like you see here, and you draw a slope to the right, like you see here. These are secant slopes. You then shorten those, you find a way to calculate those slopes, like you see here. You then shorten those slopes until they are infinitesimal in length. And you get a picture kind of like this. Okay? Imagine that there's some way to make this secant slope right there no shorter. That's not really a possibility because you can always make it shorter, but pretend you can't. Once we've done that, we can tell what the slope is going to be right here at A. Because we know this slope is that number. We know this slope is that number. Therefore, if those adjacent secant slopes were shortened, the slope right at A would have to be 10. You can tell from those values that the slope at A is going to be 10. Okay? That's how you actually find the slope at any point on a function. Is you draw two secants and you just make those secants really short. Questions? Okay. We're actually not going to, well, back up. We're going to do that. We're going to do it in a way that doesn't seem like we're doing it. We're going to use this rule sheet, these shortcut rules. And as we use these, it appears we are doing nothing with secant slopes, when in reality we are. The actual details of why the rules connect to this idea of two secants, is hidden from you. Like, we would have to spend about 3 days in class discussing how they connect. That's not a topic that is heavily tested, so I don't think it's a good use of our time. You can study it at home online if you'd like, but anyway. So here's how the rules work. Our goal is to get a formula for the slope. The symbol for the formula for the slope is that. Just like you've used for, since 7th grade. Change in y divided by change in x. So what you do is you say, okay, always write down the problem first. When I check your work, I'm always looking for the problem. So make sure you show me what you're working on. Then all you have to do is declare what you want to find. I want to find dy dx. I want to find a formula for calculating the slope of this at any point. That's what dy dx is. So I simply write down what I'm looking for.
You can also write down, like, wouldn't that just be f prime, or is that y prime in this case?
So they actually will allow you to use multiple symbols here. Y prime is correct. Y prime of x is also correct. You don't have to use all these symbols. They're just available if you want to use them. I can't use f yet unless I tell the grader that I'm going to declare this function to be f. So if I declare to the grader that I'm going to call this function f, now I can say I'm looking for f prime. Does that make sense?
Yeah.
4 points for Dylan. Anybody else? Okay, cool. So I tell the grader what I want. I want dy dx. Okay, the next step. Please make sure this step makes sense to you. I will say all year long. One reason people don't do as well on tests as they would like to is because they didn't quite go far enough at understanding the why of something. You need to keep pushing to know the why, like why we do it. So look here. I have an equation that says, or I have an expression that says dy dx. The most important symbol in this class is this symbol right here. There's nothing more important than you understanding how to use that, the equal sign. I'm going to use that right now. This says dy dx. This says y equals. So I'm going to write, oh, absolutely no doubt that this belongs here then. Because notice how everything is truly equal. The bottom here is dx. The bottom here is dx. Here's a d, here's a d. That means infinitesimal difference. Here's a y, here is y itself. Because this said right there that y is the same thing as that. Please.
Where did the E come from?
Oh, how many noticed the error? 4 points, 5 for me.
I was so confused.
I have no clue. I was so excited telling you about the equal sign that like suddenly lost my mind.
Just understood what was there.
No,
Serious
it's like, wait a
apologies for
second,
that.
how does that equal that?
I like how Mia said it so casually and in a very kind way. Like, she could have easily said, "What the?" Thank you. Sorry about that. Question. It needs to make sense to you as to why that's legal. It's all about the equal sign. All I did was take advantage of this is the same as this, so I just wrote it a different way. Question, Mike, please.
So if we wanted to just write it out like d over dx times y equals d over dx times the function, would that still work?
So here's what Micah said. Yes, and if I get this wrong, just ask again. He said, can I write this instead? D over dx. Be careful, the parenthesis has a double meaning. In some situations, parenthesis means multiply. In this situation, it does not. It means derivative of. So we would say d dx of y is equal to d over dx of 3e, sorry, I keep using e, sorry, 3 to the negative x squared. Is that what you meant, Micah?
Yeah.
Yeah, totally legal. Either way is fine. Choose whichever you like better. 4 points.
I have it in my head. Go ahead first.
Go ahead, David.
So when we have the y equals 3 raised to the negative x squared, that's telling us that like if for every x value we plug in, it'll give us the y value. So like that will help us find the xy pairs, right?
Huh?
Okay.
Perfect. 4 points. Pardon?
Got it. Okay. So if you write dy over dx without the y in parentheses, just equals d over dx, and then that function in parentheses, is that still good? Are they very flexible about the symbols as long as they're accurate and they're defined?
Say it one more time.
Okay. So like if you write it, the dy over dx on the left side of the equation, if you write it just like in one place, yes, like up there, but then you write the right side like you did on the second equation, that still works, right?
Yep.
Okay.
Perfect. 4 points. I'll say it back for the video. Carly's saying, could I have written this first, followed by this? Absolutely. What I'll try to do, Carly, is I'll try to mix it up a bit,
Okay.
just so you get accustomed to what they might do on a question. what you actually write is, either one is fine. You don't have to write them both or whatever, so. Please.
So if you're trying to say like y prime, would you do y prime equals, and then could you do y prime of 3 to the negative?
No, that actually has a different meaning. Yeah, I can't do that. I'll show later. Leave it. I can't show you everything yet, but that wouldn't be reasonable. Like Dylan's saying, can I put y prime on this side? Yes, because dy dx and the symbol y prime are exactly the same thing. That is legal. Can't really prime the other side here. I have to use the ddx operator.
Okay.
Is that okay?
Yeah.
It's perfect. Here we go.
So you can do y prime without having to declare anything else?
Yes, I could have done this. Mia's question is, can I start here, and then on the very next line, so I start here by writing the function I begin with. This very next line could have said y prime equals this. That would have been okay. Is that what you meant? 4 points. And
So all of these things that you're writing down all mean the same thing, correct? So like for us, just like if I were to like taking my notes, could I just like write down the one that like best fits for me that I would go with?
absolutely. I write all the different symbols again, 4 points, simply so that when you see a test question, if they're using the different symbols, you don't get freaked out by it.
Okay, yeah.
You go, oh yeah, I remember I don't use that, but it's one I've seen, so I'm comfortable.
Okay, yeah.
Okay, next step, for those who haven't watched the earlier videos, is the rule sheet. You have to go to the rule sheet, and you have to find a rule that fits the current situation. There are lots of rules because you're going to run into lots of situations. So, ddx, let's paste that. This is the rule I'm going to end up using. What I'm looking for is this red box right here. Oops, come on. This red box must be an exact match with this green box. There are a few restrictions here. A must be a constant in this rule. G of x is typically a function involving x, or t or whatever. All you have to do is pick a and g of x appropriately so that the red box matches the green box. So someone help me. Actually, all who know, okay, everybody. Raise your hand and tell me, what would be the right choice for a and g so that the green box matches the red box? Yeah, don't overthink it. It's not meant to be hard. Like, what does a and g have to be in this green box so that that green box is an exact copy of the red? That's how you use the rules. You just got to pick the right a and the right g. Sam?
A is 3 and G is negative x squared.
Raise your hand if you saw that. 4 points, 5%. Okay, by choosing a and g appropriately, I have made this rule, which is generic, meaning the rule is designed to work with all kinds of different functions. I have customized the rule to fit with my function. That's how you use the rules. It's all about this, the equal sign. Question? Cool. So now all we do is use the equal sign again. If the red box is the same as the green, and there's an equal sign right here, that means this blue box is the same as the green, is the same as the red. So I'm going to take away the red right here. I'm going to replace the red with the blue. That's how the rules are always used. Question? So let me pull that out of the way so we can see it.
Could you repeat that again?
Huh? So, and I'll ask you questions that'll help it stick better. So, are you okay that by choosing A and G appropriately, we were able to make the red and the green boxes exactly the same?
Yeah.
Are you okay that, according to the rule, which I just gave you, we didn't take the time to show where it comes from, that the green and the blue boxes are exactly the same?
I don't get where you're getting the natural log and all that stuff from, like how those correspond.
Oh, I changed the color on you. Whoops. Yeah, that part we haven't shown you where that comes from. I'm just asking you to trust the rule.
Oh, well then, yeah.
Yeah, no worries. The rule has an equal sign, therefore they're the same.
Yeah.
That's how I know the red and the blue have to be the same.
Okay.
Good?
Yeah.
Okay, 4 points. Anybody else? So now all you do is write down the blue box. You say y prime must equal natural log. Again, for purposes of our class, it's not crucial to know why the rule is what it is. 3. I use a lot of parentheses. I don't want to get mixed up as to what's multiplying and what's not. Raised to the negative x squared d over dx of negative 1 x squared. Question. I simply use the rule to make a substitution. The way the rules always work is it's kind of like the movie of a few years ago called Inception. If you look here, this original d dx is operating on all of the function. We use a rule. We use the exponential rule. When we do that, we actually create a part of the final answer. That part is done. There's no more calculus to be done on that piece. But the rule created a new problem. It's like it created a world within a world, like it's Inception. Now we're just working on this little piece. Okay, you always start outward, you move your way in. Please.
So I'm a little bit confused on like how to choose which rule in the very first place. And I have another question, like, do you always look at the left side of the rule as you're like, trying to find it? Is that how you find it?
Yeah, so the question Dylan asked was, how do I know which rule to pick? Second question was, do I always look at the left side? The answer is yes. You look at your work, and you're looking at the rule sheet, and you're trying to see, do I have this? Or do I have this? Or do I have this? And you'll find one of them, and typically only one. It's not like you usually have two choices. It's like you find the right one, and then you make the right choice for g of x, etc., and then you make your substitution. 4 points.
So, my question is, on the y, like, why? How did the y prime, like, equal the same as d of y over d of x?
Oh, only because somebody said it would.
That's why.
Yeah, it's just, it's
Okay.
really no different than, the reason your name is Anders is because your parents chose that.
Yeah.
Somebody chose y prime to mean the same thing.
Okay.
That's all. 4 points.
Are we going to memorize all these rules for the test?
So the question is, do I memorize all the rules? Sorry, I'm references the bell. The AP test does not allow any notes, so you have to memorize the rule sheet. Here's a point of hope. Usually when I pass this out, people, like they just go, there's no way. I have never had a single student who did poorly on this test due to memorization. If you use my notation, you stay up with the homework, you'll memorize most of them just kind of by doing the homework. Like you'll be surprised at how well you have it down. Don't leave on the bell, stay with me for just a second. Like if you talk to Lindsay, your sister, right? That's been a lot of years. I'll bet she can, with just a little bit of help, remember these. They stick that well. The main ones, there's a few that are a little more obscure, but Micah.
I was just wondering, for like this problem, how do you know if it's like negative x squared or if it's negative 1 times x squared? Like,
Gotcha.
because going through it, then it changes like what rule you're going to use.
Let me make one more statement, and then if you'd like to leave, please leave. If you want to stay while I finish the video, you're welcome to stay. Micah's question was about the negative 1x squared. Here's what I've noticed. I'm not good at sarcasm, so I will warn you that I'm going to try and be sarcastic. I have found, I'm just no good, I just feel like I'm being dishonest when I try to be sarcastic. I have found that if I write a test question and I use this symbol, I will successfully trick about half the class into picking the wrong answer. If I use this symbol somewhere in the problem, everyone gets it right. It's very interesting to me. The math's not any different. But this symbol causes a whole bunch of mistakes. This one doesn't. So what you'll see me do at the board a lot is when I see this symbol, I write this. Because they mean the same thing, and now people don't make the mistakes. That's all. Like this does not mean negative x squared. It never has. It means -1 multiplied by x squared. So go ahead and leave if you need to leave. If you want to stay, I'm just going to keep talking, so just be a little quiet as you step out. So right here, if you have questions, keep talking to me. This won't take just a couple more minutes. We have to do what Dylan said, 2 more for Dylan. We've got to pick another rule. The rule I need now is the multiplying constant rule. So I go find that.
So how can we recognize the multiplying constant rule as the same as what we just have?
The reason I recognize it is I basically just go straight down the list. And I ask myself, like I look here, Anders, I say, okay, this rule, let me get the right pen, hold on. This rule here is used when I have some expression to some number. So then I look at my work. You tell me if you're wrong, it doesn't matter, just need you talking. Do I have an expression to a number?
Yes.
What's the expression?
3 to the negative x squared.
Oh, my bad, sorry.
Oh.
When we're using the rule, we're over here.
Oh.
We're looking to see what rule has d dx, because that's what the rules are.
Oh, so now, well, because we have y prime, we have natural log 3 times 3 raised to the negative x squared. Are we now only looking at the dy over dx? Also, like we kind of just omitting the natural log part?
Uh-huh.
Okay.
Because what we're doing is we're trying to use these rules to keep, here's a better way to think about it. Our goal is to find an equation for computing the slope of the curve at any point. We have that right at the beginning. Here's an equation for finding the slope of the curve at any point.
Yeah.
With a computer, you just type that in and you're done. Like it'll do it for you. 2/3 of the AP test, no computer.
Yeah.
So I've got to come up with a more user-friendly formula. Like notice, none of the answers have ddx in them.
Yeah.
So I'm trying to get rid of the ddx.
Mm-hmm.
I use the rules to do that.
Okay.
When I used the exponential rule to go from here to here, the exponential rule eliminated the ddx from all of this.
Okay.
Now I have to do it again. So I have to pick a new rule.
Okay.
So we thought power maybe. And what I said was, if you're going to use the power rule, you've got to have ddx, which you do, of something to a number. So now you tell me again, do we have something to a number right here? ddx of something to a number.
No.
We do not. So I can't use the power rule. Please don't.
What is the, so isn't it squared?
So you're thinking we do have something to a number, which is fine.
Yeah.
So what's the something?
Wouldn't it be negative x squared?
That's the
negative
flaw.
x is the something.
Yeah, that's the flaw. It's not negative x squared. That's not what we have. We have -1 multiplied by only x being squared.
Okay.
So I can't use the power rule.
Okay.
Does that make sense?
Yeah.
4 points for Bill. Everybody okay? So I just keep looking down my list. Well, I don't have this because I don't have e to something. I don't have natural log. I don't have square root. I don't have number to something. I just keep searching. I finally found it here. I do have a multiplied by something. So I'm going to copy that. So right here.
Wait, wasn't our a in this case though the 3?
Oh, your choices for like A and G, they change every time you use a new rule.
Oh, okay.
Yeah, so those are fluid. They're not going to be the same. They're just going to keep changing as we use different rules. So paste that. And I see, so what does A have to be to make this work? Good job, Sam. What's A have to be? -1. 4 points for Mia. So A is -1.
How come it has to be -1?
You'll see in a second. Mia, what's F going to be? X squared. So now look at it, Anders. 4 more for Mia. Can you see that in this purple box, if I choose a to equal -1, and I choose f to equal x squared, that the purple box will be an exact copy of the blue box,
Oh, yeah, 'cause then it would be -1 times x squared.
which is exactly what we have.
Okay.
So that way we get the rule to fit what we have.
Okay.
If we didn't force it to fit, we just recognized that it does fit.
Okay.
Does that make sense?
Mhm.
Okay?
How do we start the next line?
No worries.
Can we just put the equal sign or because?
Oh, technically you can just put the equal sign. I'm going to keep writing y prime because too often students lose track of what we're doing. You know what I mean, Mia? They do all the steps and they're like, well, what did we find? I'm like, I don't know. I found the answer. Oh, I need a sign up here that says no answer. Like, it's the worst word ever. There's no such thing as the answer. It's what did you really do? Does that make sense? Or for me? So next line I'm going to write y prime, or I'll switch back sometimes just to get you used to the different symbols. As Anders said, this doesn't change. Don't multiply these together. That's a common error. You cannot. That's not multiplication. It's the natural log of 3. The natural log of 3 is one factor. And that's being multiplied by this, so you can't change it. It's just what it is. You really don't need parentheses up there if you don't want them. That's okay. Let's move this out of the way. The multiplying constant rule is the easiest one to memorize because all you do is pull out the constant. So now I have -1 d over dx of x squared. Question? Please, Sam.
Did you use the exponential rule on the first step?
Yes, perfect, perfect. Yeah, Sammy has a good idea. You were telling me this after class today, that it helps her as she's learning this process to just put a little note as to which rule got used. It's perfect. 4 points for Sammy. There we go. Now I have to pick another rule. So I've got to find a rule that fits with this. Which one fits with that? Power rule.
This time it is to all.
Right. Now I've got something to a number,
Yeah.
which is what the power rule is all about. So I go grab that one. One other point to hopefully help you feel like this isn't going to take forever. It feels like it takes forever when we first do a problem. It only takes a few days before we can do it much faster. So just be a little patient.
So then in the power rule, are we including the -1 times dx squared over x, or is it just the d of x squared over d of x?
So it's all about the equal sign again. So look here. You can answer it, Anders. So Anders' question is, do we worry about the -1, right? Isn't that what you said?
Yeah.
Is the -1 within the ddx?
No.
No, so we don't worry about it. Because right here we just have ddx of some expression to a number. So we just have to choose n, and we have to choose g of x to make it match. So what's g of x? To make those rules match.
X.
Well, g of x is just
X.
x alone. You see it, Carly?
Yeah.
Don't worry. And then n's what, Carly?
2.
N is 2. 4 points. Anybody else? Awesome. Now we use the equal sign. We apply the equality. Come over here. I'm going to get dy over dx. Will equal. This is the part that's kind of tedious. Just be a little patient. N is 2. G of x is x. The new exponent is 2 minus 1. Good job, Dylan. The last thing I've got to do is have a d over dx of g of x. Okay, when you get this on your paper, dx over dx, that's something divided by itself. That's 1.
Wait, how did we end up with just the dx over dx?
When we use the power, so Anders' question was, how did we end up with just dx over dx? When we use the power rule, Anders, what was our g of x?
X.
Thank you.
So look right here, you're welcome.
Oh, g of x, so it's just dx over dx.
That makes sense? Perfect. 4 points. When that happens, you get a 1 right there, there's no d of x, there's no d anywhere. Like, we have successfully used the rules to convert from a formula that only a computer can really resolve, it's just too complicated for a feeble human being like myself, to a formula that, yeah, I can kind of at least work with it without a computer. I'll clean it up a little bit. So this would be y prime equals, must keep track of the factors. There's a factor, 2 factors, well, that includes the negative x squared. 3, 4, 5 factors. With 5 factors, I can put them in any order I'd like. So it'd be common to put these 3 together first, giving me negative 6.
But don't we have the negative x squared? along with the
That's
3?
combined with the 3, so I got to put that somewhere. So I don't know, 3
Wait,
to the negative x squared.
how did we get,
Wait, so wouldn't it just be negative 1 times 2?
yeah, so would it just be negative 2?
Oh, thank you. I made a mistake. Thank you, thank you, thank you. Let's fix that. 4 points for Mia and for Andrew. So just negative 2, right, Mia?
Yeah.
Thank you.
X, right?
Yes, there is an x, thank you. And we have the 3 raised to the negative x squared power, and all that's multiplied by natural log of 3.
Oh, okay.
So I carefully find my answer there. Question? Good job, April.
That is 1 out of 30.
I totally get the feeling of like,